So I'm very happy to introduce Antonio Vassallo from the University of Warsaw. He's going to talk about grounding as metaphysical causation in space-time physics.
Thank you, Vassallo. So just to keep your attention high, let's start with a warm-up exercise. I will give you 3 propositions, each of which will lack their main verb. So then you have to guess what the right verb might be, okay? As you wish. If you have, if you feel very strongly that that's the right answer, you can yell. So the first one: the throwing of the stone, the shattering of the window. Second one: the existence of Socrates, the existence of singleton Socrates. And third one: the geometry of space-time, the motion of freely falling particles. I will give you a few moments to appreciate the underlying problem here.
Can we just put it copyright?
Sorry?
Can we just put it copyright?
So, the first one, I think the philosophers among you are very trained to guess the right sort of verb here. Let's use a tenseless language just to keep things simple. Okay? So from textbooks, we know that the throwing of the stone causes the shattering of the window. And again, from philosophy textbooks, we know that the existence of Socrates grounds the existence of singleton Socrates. What does that mean? Well, perhaps that the existence of Socrates somewhat explains the existence of singleton Socrates, and plus the existence of Socrates is prior to the existence of singleton Socrates. What about the third proposition? What is the verb which best suits the case? Well, I don't know. Sorry?
Encode.
Okay, but then you have to explain what encoding means. Okay? So, I hope by now you appreciate the discomfort that led me to embark in this project. So, it seems quite uncontroversial that in general relativity, well, let's say that a subset of material facts depends on a subset of geometric facts. However, there is no consensus over the kind of dependence that is involved here. And when I say no consensus, I can give you some examples, some glimpses of the debate. So let's start from the Bible of general relativity, the book Gravitation. There we have a very well-known motto, half of which is space acts on matter, telling it how to move. Okay? Now, of course, that's a motto. We don't have to take it literally. However, there's people who take that literally, like Alexander Bird. For Alexander Bird, according to general relativity, space and time are fully fledged agents capable of acting and being acted upon. So it seems that he is very straightforwardly committed to space and time pushing or pulling things. Okay, so his idea of dependence is causal in a very strong, let's say, folk sense. But of course, there's people who beg to differ. One of them is Vasilis Silvanius. It is clear that if we adopt a 4-dimensional ontological framework and geometrize away the gravitational field, space-time does not causally affect matter. All the geometry of space-time does is to determine which paths are available to bodies when moving inertially along geodesics. It does not enforce bodies to move in a certain way. It doesn't push anything. So inertial motion is explained geometrically, not causally. Fine. But then Andreas Bartels comes in. And he says, well, I can answer to Livanius' objection. In general relativity, the metrical, the affine structure, is the means by which the gravitational field couples to matter. Space-time affects matter not by means of classical forces, but by means of its metrical and affine structure, which brings about tidal forces producing paradigmatic causal effects like spatial deformations of material bodies. So Andreas Bartels is perhaps not as straightforwardly causal as Alexander Bird, but still he likes causal talk very much. And now let's consider Joel Katsav. Well, he says something like, in the case of geodesic or inertial motion, we have an absence of external disturbing influences. And in that case, there is by hypothesis no external influence of any object on any object that might be countered in order to ensure the persistence as is. So the only thing that might supposedly be caused and explained in such cases is the absence of inexplicable change. And this absence would accordingly have to be supposed to be caused directly. So even if you say that the space-time does not literally push things which move geodesically, well, still it seems that you are committed to some sort of causation by absence, which is not very good. So I read a lot about this debate. Of course, I felt that both parties had their arguments, and then I stumbled upon the paper by Alistair. Okay? So, in a nutshell, the thesis put forward by Alistair Wilson is that grounding is just a type of causation. He calls it metaphysical causation. So whenever, let's say, some fact A grounds some fact B, A is a metaphysical cause of B, and B is a metaphysical effect of A. So grounding is a way of causing. Now he tries to demarcate some difference between the two. So he says, if an instance of the causal sufficiency relation is mediated by a law of nature, then it is an instance of nomological causation. I will say, of course, something more about mediation later. If an instance of the causal sufficiency relation is not mediated by any laws of nature, then it is an instance of metaphysical causation. So I think that might be a possible solution, but let me first elaborate a little bit more on Wilson's thesis. Of course, his thesis is very strong. Basically, he's saying that there is a unique relation of dependence which is causal in nature. So, what we intuitively consider radically different types of dependencies, such as grounding or causal relation, are at most species of the same genus relation, causation with a big C, if you want. Okay. So why should we second that view? Now, this talk is not assertive from this point of view. I mean, I'm not defending Alistair's view. What I am asserting is that if Alistair's view is right, then we have a possible solution to the problem I have just sketched. Okay? So we'll just offer you some reasons why it makes sense to try to unify under a big C relation those kind of dependencies. So both relations usually are modeled as strict partial orderings. So they are irreflexive, they are transitive, and therefore they are asymmetric. Okay. It can be argued that those relations are homogeneous in the sense that they take the same relata, which are facts. Now, of course, the hardcore causal realist among you might say, no, the causal relation takes events as relata. But we can just say that causal relation takes facts about events as relata. We can adjust the thing very easily. Of course, both relations may play a pivotal role in explanations. We explain things by using causal or grounding notions. And this is interesting. They are conceptually bound together. They stand or fall together against objections. So, for example, there's people in the literature who challenge the transitivity, the asymmetricity of the causal relation. And there's people that on the same grounds challenge the asymmetricity of grounding. The idea is that, structurally speaking, the objections are the same. And also the way to, let's say, reply to those objections are structurally the same from a conceptual point of view. Okay, so the two notions seems to be very covering together. And the most important point, both relations can be analyzed in terms of appropriate patterns of counterfactual dependence, which, however, are of an interventionist kind. Okay, so far we have talked about the Lewisian account. I'm not considering that here. I'm considering an interventionist framework. So very, very roughly, okay, interventionist framework permits to analyze causation through some structural models. And the analysis of causal dependence along interventionist lines is done by means of interventionist counterfactuals. So let's imagine that we want to show that fact Y depends on fact X. Okay? What we do is basically to set up a model that just gives you this dependence. And the main ingredient of this model will be this sort of equation. It's not an equation, and this is why I placed an arrow here. The idea is that this relation just models counterfactuals of the form. If it were the case that X is set to some value A, then it will be the case that Y takes the value f of A. Okay? So the main idea is that you wiggle X, and as a result, Y wiggles as well. So the notion of intervention is very liberal. So we can have different interventionist accounts depending on how you place constraint of how an intervention should look like. In general, an intervention is any sort of exogenous process that sets X to the value A. So the process must be outside the chain of facts that links X and Y, and it has to be such that it sets X to the value A. Then you can have, physically possible intervention, metaphysically possible intervention, physically impossible interventions. It depends on the kind of constraints you place on your framework. Okay? So you might say, hey, this approach is non-reductive. That's fine. For me, that's a good thing. As long as the approach is non-circular. And it is not circular. Because, of course, the fact that the intervention on X is a causal process does not presuppose that we have already any causal information about the relationship between X and Y. Okay? So we want to probe the relationship between X and Y. We use something external to do that. Okay? So this is a good thing because we don't need to be metaphysically committed from the outset to some stance with respect of causation. Yeah.
So is A supposed to be written like a variable in that sentence?
This here is a constant, some value that x can take on.
So would the thing above be better written as x equals A in the parentheses or something?
You mean this
No,
one?
the one above with the
This one.
So that looks like it's whatever x is, it's going to be F in that value.
Yes, okay, I really sketched the thing. But the main idea is that there will be some chain of facts that link up to y. This chain of facts is modeled by this function f. Okay? So once we intervene at some point, in this case at the x point of the chain, then that will cause the change all along this chain. So I wiggle x by setting it to A, y wiggles by becoming some f of A. I will give you a lot of examples, so perhaps things will become more clear in a moment. So here is the first example. Of course, the window case. Okay? This is a very basic one. Of course, you can think about very, very complicated. But in that case, you have one variable c, which is just models the fact whether the stone is thrown. Another variable e that models whether the window shutters. And now those two variables just can take the value 0 or 1, depending on whether the fact obtains or not. Okay, so this can be an example. So the structural equations in this case are really simple. Just say that E depends on C. Now, if by manipulation we set C to 0, then E will become 0 as well. Imagine that, I don't know, we mount a net between the stone thrower and the window. Okay, that will be something that's set. Oh, okay, so let's say that we block, we tie the hands of the stone thrower. That would be okay. Something that models C equals 0 in the model. Okay, and this example models counterfactuals of the sort: if the stone weren't thrown, the window wouldn't have shuttered. Now, here lies the important point, that in the framework I'm presenting, the Windows case is structurally identical to the Socrates case. Now we have just to change the facts that are involved, but from a structural perspective, the equations are exactly the same. Okay? So the framework does not structurally distinguish between the two cases. And of course, since we are dealing with facts, we can make up for cases from absence. Okay, so you can model standard cases of I don't know, when you fail to water the plant, this failure brings about the death of the plant, or when unicorns fail to exist, that brings about the fact that the set of unicorns is empty. So what's the difference if we want to explain why, in fact, if we don't have in mind this kind of framework, we tend to distinguish between grounding and causation? Well, this is because basically when we justify our structural equations, we have to bring in some laws, some principles. So in the case of the window or the desiccation, we have to use laws of nature. So for example, here we might use laws of biology, if you want. Okay? In the case of Socrates and unicorns, you do not appeal to laws of nature. So in a nutshell, this is the point. And of course, and this is very important for the case we are discussing, the framework accounts for mixed cases of causation. Now, in his original paper, Alastair used an example from cricket, right? Now, since I'm not a citizen of the Commonwealth, the example was totally obscure to me. So I came up with my own example, which, surprise, surprise, involves football. So the idea is that the kicking of the ball inside the penalty area causes a penalty kick to be awarded, okay? How that happened? Well, basically, I kick the ball inside the penalty area, the ball approaches a defender's hand, hits the defender's hand, and then the referee, based on the regulation of football, decides to award a penalty. This is a mixed chain of dependency, because, of course, we can say that K depends on C, but the chain of facts that lead from C to K involve laws of nature, of course, because we have the laws of classical mechanics, for example, but also something which is not a law of nature. The football regulations are not laws of nature. Okay? So that's an idea. So it's very nice, this example, because you can see why, in many cases, some sort of reasoning which really seems causal, but from other points of view, it seems not. Under this framework is given a clear analysis. So here we go. How Alastair framework helps in the case at hand. So, of course, as I said, now we have an issue which is set in a clear framework, so we can analyze the issue in the framework. And by doing so, I think that the source of the confusion really comes up. So, we said that it is uncontroversial that facts regarding motions along geodesics, let me call as a portmanteau gamma, depend on metrical facts encoded in the metric tensor G. Okay. So if we want to write down a structural model for this dependency, we have to do certain work, which is quite complicated. So since it's 4 o'clock, I would like to keep things simple. So we'll just say that, okay, we will have some sort of relation of this kind. Okay, that can be, I don't know, a huge list of structural equations involving variables which can take infinite values. It's not a problem. Okay, we have that thing here. Now, if we want to justify those structural equations, we need to mention the geodesic theorem, general relativity. Okay? And of course, we know that the geodesic theorem directly follows from Einstein's field equation. Fine. So it seems that we have a straightforward kind of nomological dependence, causally nomological dependence. But that's too quick, I claim. Because if you think about that, the way the metric tensor singles out the Levi-Civita connection is not given by a law of nature. It's given by a mathematical law, by the fundamental theorem of Riemannian geometry. Let's say it's a fortunate mathematical fact that once you have your metric tensor that singles out just one symmetric compatible connection. Okay? So I would say that in this case, this theorem is a mathematical law rather than a law of nature. So that's my claim, that this clarifies the source of the confusion that we have solved. Because that's okay. Facts about geodesic motions do depend on facts about the geometry of space-time. But this kind of dependence is mixed, as in the case of the football player obtaining a penalty because he kicked the ball inside the area. Here is something which looks the same. For sure, the path that goes from facts, from metrical facts to material facts regarding geodesic motions can be complicated as you want, but I think that it's quite easy to understand that it will involve nomic as well as mathematical, or let's say non-nomic justification. Okay? Now, of course, if we take the dependence, grounding dependence or causal dependence as radically different concepts, then we are in trouble. Then the debate that we have seen as a justification. Okay? But if we follow Alistair's suggestion, then I think that the confusion is washed away, because here we are not comparing apples with pears. At most, we are comparing red apples with green apples. Okay. And I think that a similar point can be made in the context of pre-general relativistic physics. For example, in classical mechanics. Because there you have to justify the dependence of inertial motions on space-time structures. And if you want to justify that dependence using structural equations, well, for sure, your justification will involve some nomic facts, such as the principle of inertia. But I think that the most part of the justification would involve metaphysical consideration. Why is it so? Well, I can give you an argument. Consider two different interpretations of classical mechanics. One, let's say the standard one by Newton, and the more recent one by Nick Haggett. Okay? So, in the case of Newton, we have those metaphysically necessary entities, absolute space and time, and from them you have this standard of inertial motion, and so on and so forth. In Nick's case, we don't have anything like that. What we have a mosaic of, let's say, material facts which involve spatial relations, and from the entire history of spatial relations, we can infer laws of Newtonian mechanics as supervenient by using a Humean move. Okay? So the idea is that both for Newton and for Nick, the laws of Newtonian mechanics are the same. But they will get the dependencies reversed. For Newton, of course, we have absolute space, absolute time, and from that, inertial motions are defined, or in any case, depend on. In Nick's case, you first specify what is for a particle to move inertially. And from that, you can recover geometric facts just as the most simple yet informative description of that inertial motion. So for Nick, I think the dependencies will be reversed. So in classical mechanics, as this example show, metaphysics play a crucial role in building up the structural model. Okay? But in each case, I think that Alistair's framework gives a very clear characterization of those pre-general relativistic structures as sui generis causes or effects. Okay? So, to conclude, I think that Wilson's thesis provides a clear sense in which space-time structures play a causal role. So this feeling that space-time structure shape free motions, even if they do not literally push bodies, can be given a clear conceptual characterization in terms of interventionist counterfactuals. So the good thing about the non-reductive character of the interventionist account is that if we follow this line of reasoning, we don't need to take a precise stance with respect of causation. And for sure, we don't need causation to be something that relies on real physical relations, such as the exchange of energy. Okay? In fact, you can be very liberal. You can be sympathetic to this account, even if you don't think that causation is a fundamental relation, or even if it is a real relation at all. So the only condition for a metaphysical theory to be compatible with the framework is just that you do not structurally distinguish between metaphysical and nomological causation. Now, of course, a lot of work has still to be done, but I think that Wilson's framework is a good starting point if we want to give a novel solution to this problem of dependencies, space-time physics. Thank you.
Thank you. Now we have a comment by Karina Broker from the University of Oxford. Please.
Can you? Oh, works. Thank you very much, Antonio, for your great talk. In the beginning, you were a bit coy about committing to Alistair's framework, but towards the end, you seemed more confident. So I hope you don't mind if I push you a bit more on those. On the first part of the talk, where you're defending why we should consider grounding to be merely metaphysical causation. So you pointed out correctly some similarities about the two. One of them that they're both strict partial orders. Another one that they may be analyzed in terms of counterfactual dependence. And another one that they may play a fundamental role in explanation. And I say may since I guess not everyone would agree with these statements. However, there are also some, well, what I think are quite important differences in the relations between the relata that occur in both cases, which are completely omitted by the structural equations you wrote on the board. One of them is that causal relations are often considered to be inherently diachronic, and so that they're coupled to some sort of a temporal direction, whereas we would never encounter this in grounding relations, for example. And another one is that in the case of grounding, the ground almost by definition determines the grounded, whereas in causation the cause may not necessarily determine the effect. So my first question is hence, given the notions of causation and grounding can be analyzed in these various ways, why should I think that the similarities trump the dissimilarities? And in particular, given that in the intervention analysis it requires me to be non-reductive about both grounding and causation, am I not limiting myself immensely in the sheer ability to analyze what it is to ground or what it is to cause? And so my question is, how is this justified?
Because we saw a conclusion. So the idea is that being not limited sometimes is not good. Because if your way of analyzing things is too liberal, then you might, let's say, overlook some traits that can lead you to some unificatory framework. Okay? So in this particular case, I will say that defending some sort of common traits between grounding and causation will have a huge benefit in understanding how space-time structures work in space-time physics. Okay, so in that case, perhaps we can be a little less liberal in order to solve the problem.
Okay, so you say it's going to help us to solve a conclusion, so let me push you on this point. Sorry, it's going to help us solve a problem or a confusion, so let me push you on this point then. So you say if you apply the unificationist framework to motions along geodesics, or to this confusion there, then that helps us. You say there was an ambiguity whether the geodesic motion has nomological or metaphysical dependencies in the first place. So my first question is then, what role does the unificatory account actually play for this particular case? Because often we have various explanations possible for one and the same fact, and we encounter it all the time in daily life and in metaphysics and wherever. So for example, take the fact that Tushar is hungry. Oops, I'm sorry.
No, it's me, don't worry.
Okay.
I'm preparing.
Scaring me. All right, so let's take the fact that Tushar is hungry. So we can cash out an explanation that Tushar is hungry in causal terms, namely he's hungry because he didn't have any lunch today, or we can cash it out in grounding terms. You say there are certain physical processes that occur in his body or in his brain, and this is just what it is to be a hungry Tushar. So we can make perfect sense of there being various explanations possible at the same time to explain one and the same fact, even without adopting such a unificationist framework. How is this different in the GR case?
So the case of Tushar is, I think, you are using two different levels of reality in the explanation. Because if you use some, let's say, biological kind of facts in order to back up the dependence, you are staying at some level. But you can go even more fundamental, okay, and then justify the fact that Tushar is angry by using some physical facts. Okay. Now the idea is that you are free to do as you want, but once you settle for the kind of facts that you want to analyze the dependencies in those terms, then it is easy to look at the different links. Okay? So you say, I want to explain the fact that Tushar is angry in terms of biological facts. Then my model will have such and such connection, and those connections will be just in terms of laws of biology. Okay? But then you can analyze things in more fundamental terms, in terms, I don't know, of physics, and then perhaps that explanation, the model for that explanation will involve links that will be not just normal. Okay? So my claim is that once you settle for an analysis of the facts you want to analyze, then the framework is totally clear. You look for the links, and if you really want to distinguish the links, you can. But the idea is that you don't need to. Okay? So in your case, if we adopt Alistair framework, who cares if Tushar's being angry admits a nomologically causal or a metaphysically causal explanation? It admits a causal explanation nonetheless. So whatever level of reality you choose your facts from, the explanation will be causal with a big C. So you don't have to worry anymore about that.
I'm really worried, because now you're explaining away grounding, because one of the strengths of grounding is that it allows us to ground moral facts and mental facts, and that we don't have to explain it in terms of our most fundamental theories, for example.
Of course, if you want to give an account of your mental facts, in terms of some ontology, then you have to do some work. So my idea is that once you settle for your ontology, then this framework comes in and, okay? So it might be very well the case that you have some ontology where you don't lose these, let's say, the good effects that grounding has. Okay? But it depends on the ontology you settle for. And really, I mean, in all those cases, we can do this job without caring about your kind.
Do I have time for a last question, or shall I give it over to the audience?
No, maybe quickly. It's fine.
Okay. So couldn't I simply say, as for example Harvey Brown does, like sure, it's a mathematical fact that the Levi-Civita connection associated with a given metric field is unique, but in fact it's a physical fact that the connection is constraining matter to behave in a certain way, and this makes the geodesic equation a law of nature rather than a mathematical law. Isn't this a way out of this problem?
No, because I'm claiming that the geodesic theorem is a law of nature. There's not a problem with that. But the way this law of nature is realized in the theory involves not only Einstein's first equation, but also a fact which I think is mathematical, which is once you require your connection to be compatible with your metric and symmetric, there is just one choice. Because if that would not have been the case, then your theory would have to be some other law accounting for how you can choose your connection once you have your metric.
Thank you.
So we have several questions. Chris, and Clara, and then please.
Thank you very much. There's one thing that I think I didn't quite see, or I worry about, but that's right at the beginning, when you presented us the three propositions of Planck's. In the third one, the geometry of space-time, Planck, the motion of freely falling particles or bodies, or something like that. And then, regardless of how unified account of this Dixie relation you give, whether it's along Alistair's analysis or not, it seems to presuppose right at the beginning that in that blank you fill in some sort of verb that characterizes a relation of metaphysical dependence of one kind or another. And that seems to me already a questionable move, or a move that one could resist. One could resist along the lines that Daniel's knows to fill in the gap. Namely, the geometry of space-time encodes or somehow summarizes facts about, which are more fundamental facts about, the motion of freely falling particles. So it would be false then to say that these motions depend on the summary, just in the same way as it would be grounded or metaphysically caused or whatever. In the same way as it would be false to say that the summary of the football game, according to which the Italians didn't score a goal, is grounds the fact that they failed to score the goal. That whatever the reasons for their failure to score a goal was, it's not because some journalist summarized there's counterfactual dependence, but it's not a metaphysical dependence there. Do you see the worry? Do you take a stance in that right at the beginning in your analysis?
So my idea is that once you settle for your metaphysical picture of the world, then Alistair's framework will help you to analyze all the dependencies that are there, provided there are any dependencies at all. Okay? So in your metaphysics, it might be that in some, Humean sense, facts about geodesic motions are just a simple and informative way to describe geometric facts. Okay? So in that case, your metaphysics will tell you something about that. And when you will elaborate your structural model, of the dependencies among facts in your metaphysics, you will take into account that, and in particular, that the proposition I showed at the beginning will not hold as causes. So my emphasis was on the practical virtues of Alistair's framework. Of course, that framework does not commit us to particular metaphysical stance. So, but once we settle for a metaphysical stance, then we can be clear about dependencies using this framework.
Actually, I've got two questions that go back to the key for the second question. First of all, thanks for doing the discussion. Anyway, so in the slide in which you I mean, this is pushing a little bit more Karina already mentioned, but you spoke about structural similarities between those equations and quotes between C and E in such a way that in the
I don't know how to do that.
I think it must be a little. It says there's no C.
Okay, it's something like no source files. Just disappeared. Okay. So
yeah, exactly, this one.
Okay.
So here you say there's a structural similarity between this example, in which C stands for relativity, stands for Château, and the next one about Socrates and singleton Socrates. Now it seems to me that I can tell quite a plausible story about a scenario in the first case in which C is 0, but E is still 1. Namely, someone else, Karina, let's say, threw a stone through the window. And in the second case, it seems like I don't really have a plausible story to talk about why it might be the case that singleton Socrates exists when Socrates doesn't exist. So it seems like this structural similarity is washing away certain distinctions which we might actually think of as being useful. And so my question is, well, if it does that, why can't I see this as a sort of a reductio against the framework itself?
Okay, so of course the second example you gave can be given in terms of a counterpossible statement, not a counterfactual, right? So for sure, Alistair's framework needs, from a semantical point of view, some sort of generalization of the counterfactual semantics. So normally in the Lewisian account, we have that counterpossible statements are trivially true. Okay? In Alistair's case, we need some non-trivial conditions that tells you that in some cases a counterpossible is false. Okay? So for sure, what you are pointing at is that the framework needs some sort of non-standard treatment of the semantics in order to fully bring about this unificatory status. Okay? So, but I will say, once we do that, once we have a good non-standard semantics for evaluating all those counterfactuals and counterpossible, so that we are totally washing away any kind of difference, that's good, because this is an unificatory framework. So we want to do that. All those differences that we are discussing are just meant to explain why, if you do not take into account this framework, then it seems that you have different kind of dependencies. But if you accept the account, then this washing away, I think, is a good thing.
But isn't that sort of sweeping a problem under the rug? So this brings me nicely on to the second question that I have, which is specifically in the case of GR. So it seems to me like you can disagree with me about this being a motivation, but one of the things that I might want is an account that sort of pushes a difference between, say, it's the metric field that in some sense kind of pushes matter around, and another account which says, there's something sort of intrinsically, something intrinsic in the matter that makes our space-time description such that we're interested in, in a metric field that has these properties. And one of the properties that we're interested in is we want a connection to be torsion-free and metric compatible. And it's only once we sort of pre-theoretically put that into our list of requirements that the fundamental theorem of Riemannian geometry uniquely specifies the connection. So it seems like on this account, if you don't take into account some physical reasons or pre-theoretical reasons why we might want metric compatibility and symmetry of the connection, then yes, it washes away the difference between sort of a causal explanation in the first way that I spoke to. And second, but if you add these other conditions, it seems like I've got sort of a very different kind of causal explanation on the one hand, and this this account seems to sort of treat them as all being basically the same, which seems to me like something that I would really want in an account of.
So this account is liberal with respect of the metaphysical stances you adopt, but not totally liberal. Okay, so I think that if you are, I don't know, a causal realist among the lines of Alexander Bird, then perhaps you won't find this particular account very appealing, let's say, okay, because you really want your metaphysics to show that space-time structure push things in a certain way. Okay, so I agree with you that there might be views about the metaphysics of GR that will not benefit from this account. But I think this is a virtue of the account, that it forces us, in some sense, to trim away some of those stances. So I see it as a strength of the account rather than a weakness. And of course, Alexander Bird would be totally disagreeing with me.
So we have 3 quick questions. Again, please coffee break.
Okay, so we have some kind of clear cases of grounding and clear cases of causation, and we also have some kind of mixed examples involving both grounding and standardization. And so probably the relation between space-time and its content in the context of GR is one of these interesting mixed cases. But then my question is, why do we need to accept the idea that both causation and grounding belong to a similar ontological kind, let's say? I mean, what we need is basically just that it's possible to mix the two kinds of ontological dependency. But why do you need the further assumption that they both belong to the same kind? I mean, I guess I was a bit struggling to see why you need to accept as
from a conceptual point of view, you need, if you mix up things in order, for example, to explain why some facts depend on the others, I think you need to come up with some sort of homogenizing of the concept. Otherwise, how can you link together dependencies which are conceptually and radically different? I mean, we are not talking about, okay, there is this dependency and then this dependencies. We are talking about the kind of dependencies which is hybrid. Okay, so in justifying that dependency, you have to invoke nomological and metaphysical notions. Okay? So given that you have this hybridization of dependency, I think you need some conceptual homogenization. Otherwise, your account will be suspicious, because it seems like you are just putting together radically different things which do not match. So this is what I would reply.
Thank you for the talk. Oftentimes we read the connection between matter and curvatures being symmetric. The very first quote you showed up there was only half of the original quote. Geometry telling matter what to do, but of course we often read it the other way around as well, that matter tells geometry what to do, or space-time how to curve. So taking that suggestion and running this analysis the other way, would we come up with the same conclusion that, I guess it was, that matter physically causes, or non-logically, or not non-logically causes, metaphysically causes, whatever the term was, geometry to take a certain form or whatever. If that's, I mean, so the idea is that the equation is symmetric. The analysis you run in one direction gives us an asymmetry. We could run the analysis in the other direction, and then we get they both are causally causing each other.
Not exactly, because it depends on the kind of facts we are discussing, we are considering. Okay. Now, if you take facts about geodesic motions, then I will say that there is this asymmetry between the geometric facts that, let's say, these geodesic motions depends on. Okay, so we have one-way dependence. Now we can have other material facts on which geometrical facts depend. So think about this scenario. You have some massive body. By virtue of some massive body occupying that region, the geometry is such and such, and then geodesic motions are such and such. Okay. Now, of course, that material fact of the body being in that region is something on which the geometry depends on. Okay? But this is not the fact that you have certain geodesic motion. So the chain of dependency is the material body, massive material body occupying that region. The geometry of space-time having such and such structure due to that. Geodesic motions being such and such because of the metrical facts being such and such. So as you can see, you still have this asymmetry, but on the first leg of this chain, you have that geometric facts depend on some material facts. But you have different material facts. So in general relativity, you can have geometric facts depending on material facts, and the other way around, as long as the facts are not the same, because otherwise we would violate the asymmetry. I don't know if that's...
Last question?
Yeah, you gave an interventionist counterfactual story for what we ordinarily think of the causal relation. And it struck me that such a story might give you trouble for grounding, at least in certain cases. I mean, if you take the iterative conception of the set hierarchy, then you could have, Singleton, Socrates being grounded in Socrates, but then you'd have higher order sets grounded in Singleton, Socrates. And that grounding relation doesn't seem to admit of any natural kind of intervention, at least the way I understand interventions. Do you want to say that no intervention is possible there, or that it's sort of counter-legally possible?
So as in the case of the semantics for counterfactual, counterpossibles, also the notion of intervention needs to be suitably generalized in order to fit in the picture, of course. So you can just define an intervention as just the setting some of the variables to some value. End of story. So in your case, that will mean just setting the fact that Singleton Socrates exists to 0. End of story. Without saying anything more. Now, as long as this kind of account of generalized interventions is consistent, it makes sense, it can be used in the framework and can, let's say, account for those kind of examples that you gave.
That's a very clear answer. It does seem to me to be stretching the analogy to have to appeal to a very strange-looking notion of intervention there. I mean, perhaps you can do it semantically, but it seems to be sort of a deviant notion of intervention, at least from my intuitions. But maybe intuitions are worth nothing in this case.
But it let's say boils down to your tastes. Of course, you can say Okay, yes, this framework has its virtues, but in order to make it consistent, we have to come up with a very, very non-standard story about interventions, about counterfactual semantics, and this is enough to justify our just withdrawing it. Okay? If your tastes are different, you can say, okay, this non-standard story is required exactly because so far, being that we have just relied on a too folk notion idea of counterfactual semantics and the like, we had this problem exactly because we weren't bold enough to go non-standard. Okay? So it's something that really involves your tastes.
Maybe over a coffee break. Let's thank the speaker, Antonio.
Thank you. Thank you.